Hello everyone, welcome to Next Round Coding. Today we're going to solve maximum path intersection sum in a grid. So let's understand the problem first. So the problem says that you have a n-person matrix. I have taken here a 4x6 matrix, and you have a two players P1 and P2. P1 can go right and down, and P2 can go up and right. P1 is standing at the top left corner and wants to go to the bottom right corner, and P2 is standing at the bottom left corner and wants to go to the top right corner. So there will be a path for P1, right? Suppose this is the path for P1, and there will be a path for P2 as well. Suppose this is the path for P2, right? Now, the cells where the two paths are intersecting, these cells are called shared cells. And the question is asked that we need to return the maximum sum of the shared cell. So we need to draw the two paths such way the sum of the shared cell values are maximized. Now in this problem, we need to observe something. Suppose for P1, the path is something like this. P1 comes here to here, then here to here, and here. And for P2, suppose the path is something like this. We go straight upwards, and here to here, and again upwards, and right. The shared cell here is only one, this one, right? This one will be our shared cell, right? Okay. Now let's try to draw another one. Suppose for P1, the path is something like this. Now for P2, the path is something like this. From here it goes upwards, then right. So the shared cell will be these cells, right? Now let's draw another one. For P1, suppose it comes here, then here, then here, then here. And for P2, it goes here to upwards, then right, then upwards, then right. Now the shared cell will be here, these four cells, so if you draw more paths like this, you can able to see the shared cells will be either row wise, either column wise, or a single cell. That means you can't able to find a shared cells group which will look like this. You can't able to find a shared cells group which will look like this because P1 only can go right and down and P2 only can go up and right. So for P1 it is impossible to go from this way to left, right? Because it can go right and down. Same for P2, it is impossible to go from up way to left because it can only go up and right. So same way, you can't able to find a shared cell group which is look like this. It is not possible. Same way, this is also not possible. As P1 only can go right and down and P2 only can go right and up. So the shared cell group can't be a this kind of pattern because it is only can go right and down. It is only can go right and up. The common position would be either the right one only, means a row-wise shared cell, or if they go up and down, then a column-wise shared cell group will be formed. So now in the border position, in the border position, we can't have only one single shared cell. It needs to be a group of two or more because only one single shared cell in the border position not possible, right? If you try to draw it, you will be see that it is not possible, right? So what are the three possibilities over here? One is row based shared cell. Two is column based shared cell. And three is a single shared cell which is not in the border. So these three are the possible combination. So in the border, we need to find the shared cell which have length greater than 2, right? Greater than or equal to 2. And in the non-border place, we can find a single shared cell. But in the border place, we need to find the shared cell group which are length greater than or equal to 2. So now, as we need to maximize the sum of the shared cell values, so our problem boils down to that we need to find the maximum sub-array sum, either row-wise or column-wise, which has length greater than or equal to 2. And for single shared cell, we will check separately. Okay, now let's put it up. So first of all, we need a n which will be grid dot size and a m which would be grid of 0 dot size. Now we need a answer which is initially int minimum. So for run a loop, I equal to 1, I listen the line 2, I plus plus, or I take j equal to 1, j less than m minus 1, j plus plus. N is equal to max of as, comma, grid of ij. This will be for our single shared cell, which are in not in the border. Now we need to find the row-wise and column-wise shared cell group, which have length greater than or equal to 2, right? So let's do it for row. And there will be our rest, which will be initially int minimum, and our sum, which will be grid of I comma 0. Now just run a loop, j less than m, j plus plus. Our best will be max of best comma sum plus grid of I j. This will force us that subarray length should be greater than or equal to 2, right? Now just the standard update, sum will be max of grid of I j comma sum plus grid of I j. At the end, ns would be max of ns comma best. For row it is done. Let's do for column. Same, we need a best, which would be int min, and a sum, which would be initially grid of 0 comma j. Now we need to run a loop for I equal to 1, I less than n, I plus plus. Our best would be same here, max of best comma sum plus grid of I j. And our standard updates, sum would be max of sum comma, not sum, it will be grid of I comma j comma sum plus grid of I j. At the end, update our NS, the max of NS and the best, and return ANS with the last. So let's try to run it. Yeah, it is running fine. Try to submit it. Yeah, it is accepted. So the time complexity here is big of n into m, and the space complexity here is big of 1, as we are not using any extra space. So thanks everyone. Thanks for watching.